All right, welcome to Monday of week 10. So the end is near. A few announcements. One, there will be a hacker section tonight at 7 p.m. in the Maxwell Dworkin Cafe. This Wednesday's super section, rather than focus on old material, will instead be led by Roy, and will be a more of a detailed tour of what's called XHTML or HTML, the language in which web pages are written, and which we'll introduce briefly today, but which you'll get much more experience with the upcoming problem set. Finally, seminars. So as promised on the bulletin board, what we've put together is a menu of sorts of seminars, front and back. These are optional seminars that we may or may not offer based on interest. So your job prior to 7 p.m. this Friday is to RSVP for 0 or more of those workshops to the appropriate staff on that sheet. The purpose of these seminars is to offer you guys an opportunity to learn some material, to learn some skills that might otherwise be tangential to the course or beyond the scope of the course, particularly material and skills that you might find fun or advantageous to apply to the final project. But even if you have no intention of using any of this stuff for your final project, those of you who might like a crash course or teaser on some of this material might want to check 0 or more of those out. So, welcome back from Thanksgiving. I spent Thanksgiving reading over our survey responses that you completed for problem set 5. So there's about 300 of you. There was about 40 questions. So I've read over all 12,000 responses. Fortunately, many of them were bubbles. So that was a nice summary for me. But I did go ahead and read every one of the handwritten comments. So I do appreciate all the time you guys put into that survey, since I know it was shall we say, not short. The teaching fellows have also been provided with the comments that you gave them individually, so that they too can address, if they so choose in section or the like, the kinds of comments that you guys had. But again, it was all anonymized, so I have no idea who loved things or hated things. But I thought I would at least we certainly don't have time to address 12,000 comments in class. There were a few I'd like to excerpt, and these are fun. These made it fun to read 12,000 comments, but this is not meant to diminish the fact that we certainly will take into account either for this semester and or next semester the kinds of feedback that you guys had. But some memorable comments were in response to, "What do you think of CS50?" One of your classmates wrote, "I'm enjoying it in a sick, sick way." So that was nice. "Thanks for the candy" was another response from someone. Someone took the time to encrypt his or her responses in a Caesar cipher. Thanks very much for that. A few of you requested that we rip apart more phone books. We'll see if we can oblige. And this one was funny, but maybe kind of disappointing. When asked about me and students' interactions with me, the student wrote, "And he seems really approachable, but I'm way too frightened to go to office hours." So I don't quite know how to fix that, but I figured I'd give this a try. So one of the other suggestions from someone, so that you can contact me more often than just say office hours, the irony of which is that even though I don't have all that much office hour time officially, I'm certainly happy to meet with folks individually, which I sometimes do. But almost always when I sit there in my office, or Mike Smith's office, which I'm using this semester, waiting for folks to come by, no one ever really comes. So there's sort of an irony there, perhaps. But someone suggested tea with David once a week. I'm not such a tea drinker, so I thought I'd switch it up and make it lunch with David, if you would so like. We'll try this RSVP approach. So if you're interested in chatting with me about I don't know what, next Monday perhaps, or next Friday, or some other idea, actually it would be kind of fun to get together either in one of the houses as a small group, or somewhere else nearby. So we'll see how many, if any of you guys want to have lunch with me. Otherwise, the teaching fellows by default will be my lunch dates those days. Otherwise, just drop this email address a note if you might like to just shoot the breeze, talk about the course, talk about CS courses, and I'll try to keep it as intimate as possible if we do have a few people reply, so that it's obviously a conversation. So keep that in mind. Any questions, logistical or otherwise? No? OK, so I thought it would be interesting, on a more serious note, to give you guys a sense of what each other said on these surveys, at least when it comes to myths or misconceptions with the course, or maybe some hard facts. So this trend here, this is a graphical depiction of the answers that you guys gave, all 286 of you, to what year are you in. And these actually follow historical trends. Typically, the course is about quarter freshmen, quarter sophomores, and so forth, but with a few more sophomores each year. Perhaps that will change in time further as you guys are allowed to declare concentrations a bit later, and there's this notion of secondaries as well. But I thought you might find that statistic interesting. the registrar gave us this data as well, which is a little surprising because honestly, when I've looked out in the audience, it actually hasn't felt all that skewed. But it certainly has been a trend for as long as I can remember that there are fewer females in the class like this, or computer science in general, than males. Frankly, I'm not sure the best way to go about boosting some of these numbers other than to ask both males and females alike to invite your female friends perhaps to consider the course next semester. But this is a more interesting question than we have time to address this morning, but I thought I'd at least give you the data to give you a sense of who you're around. So this is perhaps the most important piece of data that I wanted to show, because a common thread in emails to me, in anonymous comments on the bulletin board or whatnot, is this conception or misconception that everyone else in the course knows more than me, or the course is filled with all these uber geeks who took AP Computer Science in high school and did really well on it, shouldn't be in this course and the like. I offer this data just to suggest that I really don't think that's so much the case. I think the typical student in this course is someone who's either in between or a bit less comfortable. So this, granted, was your own self-selecting categorizations of each other, but 30% of you put yourselves in this euphemistic, a less comfortable category, 20% of you in the more comfortable category. And notice, 20% in that so-called more comfortable category, which is actually smaller, hopefully, than some of you feel that it might be. And then a good percentage of you, about half, are somewhere in between. And that's probably to be expected as well. So at least take that for what it's worth, and at least let that put into perspective that you have many friends, perhaps 30%, upwards of 90 fellow students who are in that less comfortable category. And 90 students, 88 students, that frankly is sort of a course unto itself. So you should not feel so alone. Prior experience is a related question. So about half of you came in with no prior experience in terms of programming. About half of you came in with a little, and a few of you, 10%, came in with what you described as a lot. Granted, these are your own categorizations for that as well, but it also puts into perspective, perhaps, just how relatively few, 10% of the students in this course, feel they came in knowing perhaps most everything the course aspires to teach. So perhaps take that for what it's worth as well. And then just to maybe reassure you, to frighten you as to how much time the people sitting next to you are spending on these problem sets. To be sure, there are these crazy kids who are spending 0 to 5 hours on these problem sets. But realize that they do number significantly in the minority, and that's quite all right. And the sweet spot in the course does seem to be in that 5 to 10, 10 to 15 hour block, with a non-trivial number of you taking 15 to 20 or even 20 or more hours. I think that you might feel a little angst if the 20+ bucket contained just one response, right? That might be something, some cause for concern. But again, 19 students. There's a course unto itself. 48 students is a course unto itself. So there, too, clearly there's a spectrum of abilities, of comfort levels, of the amount of time it takes folks to tackle this course's material. But just realize that there are other people like you. And so at least take comfort in that fact as well. And frankly, I'll put it out there. I myself, when I took the course, I was in that 10 to 15 hour block. So I wasn't even among the super geeks in the 0 to 5 or even the 5 to 10 category. So I'll put myself up there as well. All right, so this is a sneak preview of a sneak preview that you'll get in just a week or so's time. So we'll be having a couple of guest lectures toward the end of next week and the beginning of the week after from faculty in the computer science department to give you teasers as to what you can expect in a course like CS51 and what you can expect in a course like CS61. I will defer largely to these descriptions and to those faculty members when they arrive, but the purposes of those two lectures will be to give you a sense, not just if you're a computer science concentrator, but what you as a non-concentrator can go on to do with, say, just one more perhaps terminal course in computer science. And I'll say from experience, I think the marginal returns of CS50 or a course like it are pretty damn high, especially if you've come in not having ever programmed before. Most of you will exit this course, even if you entered it pretty uncomfortable, will certainly exit it much more comfortable. And that is to say, CS50 can be a terminal course for a good number of students. That is the last course you ever take in computer science. But I will absolutely say from my own experience that it wasn't until after taking a second course in computer science, happened to be CS51, but a second course, 4 more months of computer science, 4 more months of programming, that I actually felt myself truly comfortable and truly a programmer in my own mind, in the sense that after CS51, I was able to pick up, say, a book on some new language like Perl and just teach myself that material. I was able to sit down and frankly write something like Shuttle Boy, which I had never written something like that before. It was certainly not like any of the problem sets we had done in 50 or 51, but I had that comfort level myself. And so this is only to propose that if you like this stuff and you want to acquire even more comfort, certainly consider, even if you're not a concentrator, diving into, or shopping at least, one of these two courses, the latter of which is brand new. And so Matt Welsh, the course's instructor, will give you a more detailed sense of what that course will be like. But both are quite fun. And frankly, it was my second course in computer science that set me off on the path toward computer science that I'm now on. So any questions at all? No? OK, so a couple of yep. Sorry?
What was your second course in computer science?
My second course was CS51. So that is the typical path here, but folks can go on now to CS61. CS124 is an option. CS121 in the fall semester is an option as well. And so those of you guys who actually have questions about this can certainly chat with me or most any of the teaching fellows who have gone through most of this before as well. So I'll return to this plea later in the semester, but just a teaser that we've already begun the process of looking for help for next year. So the plan is for me to indeed return in fall 08 to teach this course again, and we are especially since it was not ideal doing some of our recruiting in October this year. So we're going to try to do it in January for the following fall. So we will be looking for folks over the next few weeks, if not months, for teaching fellows, graders as well as coders. And by the last, I mean we're going to take on a number of programming projects ourselves over the next few months to develop some internal tools that will help optimize our own workflow in the future. We've got a lot of interesting ideas that I think we'll experiment with in the fall in terms of making the course better for your classmates, your peers, next year's students, but more on that in the final week of the course. But if you're less comfortable, if you're more comfortable, that's fine. We're going to be looking for folks of all types, especially since some of our teaching fellows are graduating this year. All right. So the year was 1995. And let's see, how was this story supposed to go? OK, so the year was 1995, and I was taking Math 20. And my CA happened to know HTML. I didn't know HTML. I think let's see, I hadn't even taken CS50 yet, because this was freshman year for me. And for some reason, he and I got to talking after math section one day that I'd love to learn HTML. So we walked down to the basement of the Science Center. I think we logged into one of the terminals. He spent maybe 30, 40 minutes showing me the basics of what's called HTML or XHTML, the language in which web pages are written. And long story short, I went back to Matthews Hall that day, taught my roommate as well, who was even more of a geek than I. And mind you, 1995, there was barely a web. This was the beginning of the popularization of the internet, so most folks did not have home pages. But later that night, both he and I did. And rather pathetically, we went on to spend most every waking minute for the next week or so making the most hideous of websites, blinking tags and little things spinning around, no sense for color or aesthetics. But it was fun, frankly, and it was easy, relatively speaking. And actually, I was reading the Crimson this morning, and I know this week and last week, there's been a lot of attention on these upcoming UC elections. And the other quick story I'll tell is that so I actually think I became a teacher because I sucked at public speaking, ironically. And I learned this when I ran for UC president junior year. And I, in a nutshell, did very poorly in the UC debates that at least they had back in the day. I don't know if they still do these now. And I just felt myself rather bad at speaking. So that's meant to be look at what you can do, perhaps. You can go on to teach a course at Harvard, even if you lose the UC elections. But I bring it up because I went through my archives and found this hideous thing. So here's sort of rule one, how not to make web pages. Don't have stupid little blinking things that say click to enter. Just let the user enter, first of all. So if you click this, and this was embarrassing looking through this last night. Let's see, come on. Come on, HCS. Actually, this might be a good thing for me. So EECS's server isn't quite responding. Come on. Oh, that might be the only teaser you actually get. All right. Oh, no. All right, well, had we been able to proceed, I could have given you my campaign platform, a letter to freshmen that I wrote. What was really sad about the site is that it had, for some reason, these really big blue dots sort of demarking each of the points that I wanted to make in that UC election. I don't know. I mean, as of a few days ago, the thing was, oh, there we go. About me and my platform, campaign posters. You're not going to see those. That was bad. My platform in detail. So this was indeed detail. Frankly, I kind of wonder if I have a second chance, right? Because the UC elections, as I understood them up till a few days ago, were pretty much uncontested. So I already have this website put together. And I don't know if you can write in candidates these days, but maybe this year it'll be my year. Anyhow, vote for Malin if you can this year. All right, so that was one of the first web pages I made just a couple semesters after having learned HTML in the first place. And what the next segment of this course is about, this week and next, is in teaching you guys yet other languages. Not just programming languages, but markup languages, HTML as well. To convey a number of points. One, the fact of the matter is that software these days is increasingly web-based. So the fact that we will be, for problem set 7, working within a web-based environment instead of a Linux command line-based environment is reflective of this reality that more and more software is moving toward the web. Case in point, consider what Google has done with Writely, with their documents program, with their spreadsheets program. All of this stuff is migrating to the web. And frankly, I think that's an inevitable trend. Whether it's Web 2.0, Web 3.0, I do think we'll likely see a migration away from the Microsoft Office incarnations of the world where it's running only on your local machine. So in that sense, I think this kind of material is particularly germane. Two, what you'll find after taking CS50 and or 51 is that in the future, there's not going to be most likely someone holding your hand teaching you the next language you learn. There's not going to be a problem set walking you through step by step everything you need to type to get yourself up and running in a new environment with a new language. So as important about this part of the course is the fact that we're going to give you some exposure to new material. HTML, cascading style sheets, PHP, and SQL, but not very much of any of them because much of this process is designed to be a learning experience for you guys as well. You have these programmatic constructs under your belts, loops and conditions and booleans and functions and all these basics that frankly are common to most any common programming language today. And much of the process of learning a new language is about figuring out things for yourself and asking questions. Frankly, the only languages I ever learned formally were C in CS50, kinda sorta C++ in CS51, and Lisp in CS51. I never again took any formal course in programming that taught new languages. Rather, I taught myself things. There's a lot of books called this, but Teach Yourself Perl in 21 Days. Well, I checked that book out of the library, I think, around the time I was trying to make that freshman intramural website. I think I read like the first 7 days worth of the book and just have been figuring out things ever since. When I need a new skill, I need a new function, I ask a question of someone, I look it up. And much of this process for problem set 7 will be about exploring things on your own, exploring PHP, and asking questions. However, to provide you with a support structure, let me explicitly recommend these resources. So these are some wonderful tutorials freely available online. There's really no reason to go buy a book that's this big for some reason as to how to write web pages and the like. But I would suggest this week, or certainly this weekend, before you tackle problem set 7, do flip through, do read over one or more of these tutorials with an emphasis on the language-oriented ones, XHTML, PHP, and the like. This is an expression in computer science and beyond, RTFM. So this is only, Google it if you've never heard it, but if there's one thing you should constantly bear in mind as we proceed to problem set 4, and some of you to the final project, I can't emphasize enough how valuable with a language like PHP its user's manual is. And it's not a user's manual in the sense of it's a 100-page book that you flip through reading. It's a reference manual. It's searchable. So much like that C++ resource website that we've been pushing you guys toward, same idea. If you want to figure out what function will get some job done, you do a quick Google search and you'll find it in the manual, or you search the manual itself. Frankly, most of the time when I'm asked questions these days by friends, how do I do X or Y in PHP? I Google it, or I quickly look it up in the manual, and then I reply. I learned myself PHP over Instant Messenger by chatting with a friend. And it sounds a little silly, but I was looking through a manual or a tutorial like one of these. I was like, OK, I kind of get that. Oh, I'm not sure how to do this, so I am my friend Dan, or whoever it was on a given day, and just ask questions. And I can't emphasize again enough how many questions you should expect and should feel comfortable asking of each other for problem set 7, as well as the staff. And to do that, I would strongly encourage you to use the otherwise underutilized bulletin board. So those of you, and this came through on the surveys as well, in response to what do you think of the course's anonymized bulletin board? Non-zero number of responses were there's a bulletin board. So yes, it's under, you can find it under the bulletin board link on the website. But notice if you've been this out of touch of the bulletin board, notice you've missed out on 872 posts related to problem sets over the course of the semester. Certainly don't go sifting through all of those now, but know that this is available as a resource. And for better or for worse, my OCD seems to guarantee lately like 2-minute response times to bulletin board questions. And I say this actually in seriousness, given how much more of a weight there tends to be physically in person at office hours. So those of you guys who are waiting there, struggling with some of the material, waiting for a teaching fellow or myself to come by physically, know that there are multiple staff members who are obsessively on email and on the bulletin board keeping an eye out for questions. So do make use of that as well. Whew. All right, ready to learn about the internet? All right, so every computer on the internet, small white lie, speaks a language or protocol called TCP/IP. So a typical scenario these days, certainly for you guys at home most likely, is that you've got a desktop computer or a laptop. You've probably got a cable modem or DSL modem depicted there at far right. And then you've got one of these home routers or these wireless routers, aka gateways, aka access points. It's that thing that you connect to the modem that lets multiple people in your house or your neighbors connect to your Comcast or the like connection. So what's going on here in a nutshell? And we don't really need to understand all of the details of the internet to start writing things on the World Wide Web, but at least to give you a sense of the domain in which we're about to start playing, let me give you the following basics. So every computer on the internet, again, speaks this language, this protocol called TCP/IP. Well, what does that mean? That means that every computer on the internet, again, small white lie, but works for us today, has what's called an IP address. An IP address is just a number of the form x.y.z.w, where each of these is a number from 0 to 255, subject to a few constraints. Okay, if you've ever plugged your computer into the network here, if you've ever done something or seen a friend do something like this on a Windows machine at least, if I pull up a little command prompt here and type ipconfig, which your friendly user assistant might have done on your computer at one point, you'll see such things as IP address 140.247.40.240. is my current IP address of this laptop on Harvard's network. That address was auto-magically assigned to my computer by FAS's infrastructure, namely a DHCP server. But what does this mean for us? Well, this means now that my computer has a unique address. Much like a US postal address uniquely identifies a house, say somewhere in the world, so do these IP addresses uniquely identify, in theory, a single computer on the internet. And there are these things on the internet called routers, these super fancy machines whose sole purpose in life is to route data from point A to B. And what does this mean exactly? Well, obviously, you know that if you pull up a web page, you don't have a physical connection from, say, my computer to CNN.com or Harvard or Stanford.edu. So there's multiple hops in between me and these other destinations. And those hops are called routers. They're typically owned by different entities, different ISPs. But long story short, folks who created the internet figured out how to route data in such a way that point A's data eventually makes its way to B. And it knows how to get there because of these things called IP addresses. And just to make this a bit more real, let me actually go ahead and run a command on my computer. We'll see if this works, called traceroute. This exists on Macs and Linux machines as well, perhaps with a slightly different syntax. And if I do something like, let's see if this works, Stanford.edu, which is, of course, in California, if Harvard and other people's servers are not filtering in an annoying way, what we will eventually see, and I'm going to do a second can demo from here just to see if this is going to work better. Trace route. Let's try CNN.com, see if we get better. Trace route. Oh, that's nice. It's not on there. All right. So if Harvard's network or other ISPs weren't filtering, I'll try to whip this up tomorrow, later today or on Wednesday. What you'd be seeing at each of these dots on the screen is the name or the IP address of a router between point A and point B. And actually, that's a little lame for me to do that. So let me do this. Mail-in at, let's try ICE. OK. I'm going to connect to one of Harvard's other machines that runs a different operating system in hopes, there we go, CNN.com. Well, that's just completely wrong. All right, let's try stanford.edu. That's not how it's supposed to be responding. Let's try one other gesture. Let's try HCS and see if their machine responds in the way that we want it to. OK, so trace route. Let's try it again, CNN.com. All right, there we go. All right, so what you've just seen, it's a little ugly formatting because the font's a little big. But notice that in the very first line of output there, we see that it says traceroute to www.cnn.com. And then parenthetically, it's telling us what the IP address of that machine is. Each of these hops now represents one of these things called routers that are in between point A and point B. And for today's purposes, suffice it to say that the internet knows how to get data from A to B because of this language that computers speak called TCP/IP. And as a neat aside, you can sometimes infer where your data is actually going. So these things here obviously are routers that belong to Harvard. Down here, it looks like this router belongs to a big ISP called Quest.net, which Harvard directly, I think, connects to. Those are both in Boston. EWR, airport codes, tends to be the convention for naming routers. So this is probably in Newark, New Jersey. So that means that there's a hop between Boston and Newark that data from point A to B traverses. DCP, I don't know what that one is. Anyone? OK. And then it doesn't look as clear down here. But actually, let's do one more just to make this more real if we can. CNN.co.jp, if that's right. Let's see if we get a neat effect here. And this is more of an aside than I intended, but we'll move on right away. All right, so the spoiler for what you're about to see, and you can play with this at home. I'll make available the command on nice.fast, so you can just try it there. But what it will eventually do is eventually encounter an ocean, most likely, between here and CNN's web servers in Japan. And if this demonstration eventually, there we go. Where's the ocean? Right? So I didn't tell you what these lines mean, but there do seem to be milliseconds mentioned. And recently, they shot up from only about 5 or 10 milliseconds to 200 milliseconds. So it looks like there's an ocean between the routers identified by routers 6 and 7. So there's some kind of transatlantic or transpacific cable that's actually carrying data over to Japan from my little old laptop here. All right, so that's just to get you excited about how cool the internet is. Now let's actually do something with it. So the World Wide Web, as you know it, is just a service, so to speak, that runs on top of the internet. So the internet is like this physical infrastructure that has these software like TCP in place so that data can get from one point to another. Well, the language specifically that web servers and web browsers speak on top of this physical infrastructure called the internet is HTTP, Hypertext Transfer Protocol. And this, too, is just a set of conventions. It's a language, if you will, that a web browser and a web server speak when intercommunicating. Well, what does this mean? Well, as this picture suggests, albeit in very minimalist form, if my computer here on the left is requesting some web page, say of CNN.com, well, what my computer does is it sends a message on the internet that says, effectively, get / and then something like HTTP 1.1. So literally, my browser, say Internet Explorer, when I type CNN.com and hit enter, it sends a message. And not really an email. It's a different set of conventions, but similar in spirit, from my laptop to CNN server. And there's sufficient infrastructure in place on the internet that my laptop and the routers between it and CNN can figure out how to get this message, this HTTP message, from browser to server. So upon receipt of this message, the server, CNN server, realizes, oh, well, this user is requesting the so-called root of the web server. So if you've ever looked at a really properly formed URL, it's usually something like http:// cnn.com/. for the home page. And if you omit that, your browser typically puts it there automatically. And that just means the root of your hard drive, the C drive, so to speak, of that web server. If, however, you specify a specific file name, well, it turns out that you can specify things like index.html. And that means don't just get the default web page for this website, but more specifically, get the file called index.html that's on this web server. And let's see if we can't simulate this. So if I go to http://cnn.com, enter, OK, we get the day's news. Slowly, but we get the day's news. All right, if now instead I do http://cnn.com/index.html, let's see what I get now. Looks like I get the day's news. So what's going on? Well, it turns out that for most websites, the default web page, that is the file that implements the thing you see as the home page, tends to be called index.html, just by convention. It can be called other things, but if you just say /, the web server typically assumes, oh, this person wants a file, a text file, an ASCII file called index.html. So what today and this week is all about is beginning to write files like this in a language called XHTML or HTML, the distinctions between which I'll make mention of. So we have TCP/IP, which is the language that computers physically speak on the internet to just get any kind of data from A to B. And then HTTP is, in effect, a language on top of that. It's a language that specific programs, like a web server and a web browser, speak when communicating on or using this internet. In turn, though, the language in which the files are written that are going to be returned as a result of this chatter in HTTP is HTML. And if you didn't understand all of those layers, that's perfectly fine. You can spend a whole course, CS143, exploring these kinds of details. But take away then for today that the language in which web pages are written is called HTML or XHTML. And that's the kind of stuff that we're going to start looking at today. And it looks quite simply like this. All right, so don't go adding to your resumes today that you know 2 programming languages, C and HTML. So HTML or XHTML is not a programming language. It's a markup language, the distinction between which should become clear over time. But in a nutshell, it just means that HTML doesn't let you implement logic, like conditions, and it doesn't let you call functions per se. It doesn't let you have Booleans and the like. It's purely aesthetic. And in a nutshell, and as a teaser, what HTML is going to allow us to do is write something like this. If I want to make a very simple web page that just says the word foo, but I want this foo to really stand out in my web page, well, HTML is a markup language in the sense that you can mark up the actual data you want to display with what we might call metadata or tags. The convention is if I want to make a word like foo really stand out, look boldface on a web page, we're going to do something pretty simple like open tag b close tag, open tag /b close tag, and that's it. We've just marked up the word foo and have told whatever browser tries to read this data that it should, yes, display FOO, but it should display it in boldface. And we'll see other tags, so to speak. This is a tag as well. I is for italic, U is for underline, and there's a whole bunch more control that you'll be able to exercise. And lest I forget later, know that we've printed out quick reference guides of sorts today. These aren't meant to be tutorials by any means, since if you glance at this page in particular for HTML doesn't tell you how to use the language, but rather it's meant as a one-page quick reference guide to what tags you might want to use. And then I would refer you to some of those online tutorials that we put on the slide and also have linked under resources on the course's website for figuring out how to use some of these tags if you've not seen them in lecture or section before. So let's begin. Let's make myself a web page. So we had FAS Computer Services create an account for us called CS50 stud. It's meant to denote student, but we can call it CS50 stud and think ourselves a bit cooler. If I'm going to go and I'm going to access this account as follows. So you guys having FAS accounts obviously can SSH to nice. But you guys with FAS accounts can also host web pages on FAS's servers. And because of some annoying naming details, your web page is not going to be at http://nice.fas.harvard.edu, but rather www.people.fas.harvard.edu. And then at the end of that, as you'll see, you're going to put the convention /tilde username. And what this means is pull up not FAS's default homepage, but rather the one that belongs to this user. All right, that's all that means. And all of the file servers are shared between nice.fas and www.people.fas. The course uses www.courses.fas. So these are different web servers, but they all have access to the same hard drives, in effect. So you have your data on all of these machines, even though the URL might look a little different. So I'm going to try pulling up CS50 Stud's homepage on people.fas.harvard.edu, CS50 Stud. All right, nothing too magical there just yet. So clearly I need to do something to actually put a file up on the web. And notice here, it's very subtle, though some browsers make the error more obvious. HTTP 404, well, you've probably seen this error on the World Wide Web itself. What this means is that file was not found. So 404 is the esoteric code denoting file not found. HTTP was the language Internet Explorer tried to use just now to go get my default home, CS50 Stud's default homepage, namely index.html. So if the browser's saying, subtly, but 404 error with regard to HTTP, that just means CS50 Stud doesn't have a default file called index.html. So let's do that. Let's make this stud a web page. So I'm going to go to nice, and you can continue SSHing to nice as usual. Here's my home directory. Nothing's in it, right? I've just started the course, though if you guys do this, odds are you're going to have at least that CS50 directory. So now it looks like your account, and probably there's a big mess of files in there as well. So there's a few commands you'll need to type to do this, and these skills apply not just to FAS's machines, but really Linux-based web servers in general. So this is a transferable skill, and we will walk you through these steps in the problem set itself. So you needn't memorize these things, but I'm going to type a few commands. I'm going to type chmod, chmod, which changes the I think it stands for change modifications. Anyhow, it's the command that allows you to change the permissions of a file or directory. Because obviously, if I'm trying to make a web page, I don't want to keep this thing readable only by me. That is, I want everyone to be able to read it. But for privacy's sake, all of your files on nice.fast thus far, by default, have been readable only by you. This is why we, the staff, can't just poke around your directory to figure out what your bug is. You need to give us your code, or you need to submit your code so we have access to it. Because by default, only you can read them. But I need to do a few things to get myself started. I need to run chmod on my home directory, denoted by this tilde. And then I need to make a special directory called public HTML. All right, this is a convention on a lot of web servers. You know mkdir already. If I type that, I now have this directory. I'm going to go into it. And now, in this directory is where all of my web-related files need to go in order to make a web page. So that file I mentioned earlier, index.html, ultimately needs to reside not in my CS50 directory, not in my home directory, but in my public HTML directory. The idea of which is that for privacy's sake, only the stuff in this directory will be disclosed publicly to the world, thereby giving you clarity as to what's public and what's otherwise private. You're going to have to run this chmod command again, but again, we'll walk you through this in the spec. You don't need to worry about the details now. But I'm going to go ahead and run nano index.html. I have a blank file now. I'm going to cheat. I'm going to offer for consideration that this is the simplest web page that you can make that is pretty darn boring. This is a hello world web page. But just to save time, I'm going to ugly. Ignore what I'm about to do to avoid the indentation issue. Now I've just opened Nano, and look how pretty it came out. So it's a little hard to see. I'll fix the colors later, but we know that this stuff looks like this. And granted, it probably does look like Greek to you now, so to speak. But take a big guess as to what this web page, when I pull it up in IE, is going to look like. It's going to say, hello world. Right? So let's take a look. I'm going to have to run a quick command here to make it world readable. But again, the problem set will tell you how to do that. But now I'm going to go back to IE, reload, and there it is. I have CS50 Stud just made my own presence on the World Wide Web. Now let's tease this apart. Let's try to do something more interesting with this. All right, just to fix the colors, I'm going to use a program called Vim instead of Nano, just to change the color scheme. Now it'll look a little brighter. But let's tease this apart. So for today, take it on faith that to write web pages in a language called XHTML, which for those of you who have heard the term HTML before, HTML, long story short, is a very sloppy language. You can just kind of whip something up in it, and the browsers figure out most of the time what the programmer meant. XHTML is much more precise, as you will see. You have to be much more careful as to how you express what you want to display on the web page. And for a computer scientist, that's a wonderful thing, because you should be thinking clearly, carefully, expressing yourself precisely. From a computer's perspective, it's a much better language in theory, XHTML, than HTML, because the browser doesn't have to do as much guessing. It's much clearer, as you'll see over time, to write web pages in XHTML. But for now, you can think of them mentally as largely the same. But for XHTML for this course, the top 3 lines of your file must be literally this. And in 10 plus years, I've never once memorized this line. I just copy and paste it from past pages I've written, and that's fine for you as well. So how do I make a web page? Well, I'm going to delete all of this and just tell a quick story. So every web page that you write has to start with these things called tags, specifically an HTML tag. And this is a stupid little detail. Even though we're writing pages in XHTML, the tag is called HTML still. That is what the world decided a few years ago. So every tag in this language, in this markup language, that you open, so to speak, with a tag like this, you must symmetrically close. So much like I said, start making this bold, stop making this bold, similarly must you get into the habit of saying, start my HTML page, ... stop my HTML page. Well, what else can you put inside of these tags? Well, there are 2 main parts to any web page, a so-called head and a so-called body. So the head is going to be between 2 tags called open head and close head. Body is going to be between open body and close body. And you can describe these tags in different ways. But again, to be clear, the jargon is this is an open tag or a start tag. This is a close tag or an end tag. But call it whatever you want. It's just semantics. And now what I have is the general structure for a web page. The head of a web page tends to refer to stuff like what's in the title bar, way up top here. Not much at all, but some basics, like the title of the page and a few other things, as we'll see. The body is the juicy part of the web page. It's the stuff that really constitutes the web page in the true sense. So let's change the head to say a title of my second web page, close title. OK, now I'm going to scroll down to the body, and I'm going to say hello for the second time, exclamation point. All right, I'm going to save it. I'm going to go back here and reload. And now I have my second web page. All right, still pretty boring, but let's see what we can do with these basic constructs. I mean, the neat thing about HTML, and the reason that my CA in Math 20 was able to teach me this stuff, not all of it, but teach me the basics in like 30 minutes, 40 minutes, is because it's largely self-explanatory once you know the basic concepts, and it's a very bootstrappable language. That is to say, once you know a few basics, pick up the sheet and figure out, oh, I see, I can make something italic using this tag. Or how do I do this? You Google it for answers. So I will say, and I'll try to make this more clear in problem set 7 spec, I think we will encourage, far more so than past problem sets, seeking out answers to your questions via Google, turning to the web for examples. Because frankly, the way in which you tend to learn things like this, how do you make a web page look like ours? Well, right-click it, choose View Source, and there you have it. Here's all the XHTML that I wrote, or wrote programs to write, that collectively implement the web page, the home page, for CS50's website. And I mean it. I mean, these days, most websites are kind of too complicated for a noob, so to speak, to figure out how it's implemented by looking just at the source code. Frankly, what you just saw briefly might overwhelm most of you. And it should. It would have the first day I saw HTML. But that's a useful trick for figuring out, once you get comfortable with this stuff, oh, how did they do that? Or how did they make their web page look like that? And so we'll make this clear in the spec for problem set 7. But you'll be encouraged, far more so than in the past with respect to academic honesty and the like, to go figure out and learn from other people's examples by turning to the web and fellow students. All right, so let's make this a little sexier. All right, so this is perhaps the second most boring web page that I can make. Let's at least do something like this. I'm going to change the background color of this web page to be something other than white. So to do this, you can typically control the style of a web page using this other language called CSS. Cascading style sheets, of which we'll also give you a teaser, and which has some more details here, and also the tutorial online offers more details as well. But long story short, XHTML is largely used to define the structure of your document. Where do you want things positioned? And then CSS, as you'll begin to appreciate, lets you go that final mile and really fine-tune the aesthetics of your web page by changing font size, colors, positioning, and things like that. But for now, just know that what I'm about to type is an instance of CSS. But for now, you can just think of this as all wrapped up in this thing called XHTML. But it turns out the way you control the background of a web page is you can do this. Background equals, let's make it pretty ugly, yellow, semicolon, close quote, close bracket. So here's the other lesson. What I've just introduced is this construct known as an attribute. Attributes are things that modify the behavior of an HTML tag or XHTML tag, typically by controlling its aesthetics or its positioning. And the syntax for that is to specify attribute's name, equal sign, and then in single quotes or double quotes, so long as you are consistent, you put the value of that attribute that controls the behavior of this thing. Well, this, quite simply, should make my whole web page yellow. And, in fact, it has. So we're approximating now the third web page that I made as a freshman after having had a crash course in this. Let's make it more hideous. You can, using a tag called div for a division. Think of this like a paragraph, but just more generalized. You can put things centered. So I'm going to say div align equals center. Now, how do I know that's possible? Well, at some point someone told me, or I looked it up and figured it out. Now you guys know, too, how to make something centered. But I've got to close this thing so everything is symmetric. Save it, reload, and there we go. Step closer. Now let's make this thing not only ugly and yellow, but also huge. So I'm going to go into div, and I'm going to specify a second attribute. So with tags, you can have 0 or more attribute value pairs, so long as your syntax is correct. So I'm going to say style equals font size. Let's make this huge, 72 point. All right, close quotes. And you don't need these semicolons formally, but if you start controlling multiple properties at once, you'll see why they're useful. I'll do that in a sec. Let's go ahead and reload. Wow, there we go. It's really getting ugly. All right, so let's change one other thing. Let's change the color of this font to be, how about green? All right, that's pretty hideous. Yeah, all right. So now we have green on yellow. And just so you've seen it once before, you can actually use hex codes. So we introduced these, recall, back in problem set 4, RGB codes. So if I want green, I can also say no red, give me a lot of green, give me no blue. OK, so you've seen those kinds of codes before. And you can look these up online or just infer them as well. So it's a different shade of green, but that is, in fact, true green now. So that's another trick you can use. But now let's do something that's common in web pages. Let's add an animation. So it turns out the most popular type of graphics for web pages are things called GIFs or JPEGs, PNGs as well, PNGs, which you had a bit of an intro to on problem set 4. Bitmaps, not so much. That's more of a Windows thing for the most part. But GIFs and JPEGs are quite popular. Let's go ahead and let's see. What's a really ugly thing we can put here? Oh, that's perfect. All right. So I'm going to assume for lecture purposes that it is fair use for me to use this in my own web page. So I'm going to right-click this image. There are different ways to do this. I'm going to save picture as. I'm going to save something called, let's see, image.gif on my desktop. All right. Now I have this file over here. What I'm going to do now is use SFTP, which you should have used more than once in the past, most likely. I'm going to log into CS50 stud. I'm going to go ahead and type my password. Notice here I see the same directory structure. So I'm going to go into public HTML, and I'm going to upload image.gif. Okay? I'm going to have to run a command now to make sure that it, too, is viewable on the web, which we'll present in the spec. But now let's go ahead and integrate this. Let me put another division. And you don't necessarily need these. You'll realize with XHTML, there are a bajillion different ways to implement the same aesthetics. There is no one right answer. There are different ways of doing things. Here's just one way. Now let's go ahead and embed an image with the img tag. They like to take shortcuts and not spell out whole words to save times. The source of this image is going to be image.gif. And then, and here's something that's key to note, with an image, it doesn't really make conceptual sense to open an image and then close an image, because what are you going to put inside this atomic entity known as an image. So you can either, in somewhat silly fashion, just close it immediately, and that's acceptable and correct. Or the convention really is to have a so-called empty element, an empty tag, which means you put a / inside of the open tag. And what that does is it simultaneously opens it and closes it, which frankly I think is a little more elegant. You can have or you don't need to have the space. It's up to you. All right, let's save this. Go back to my web page and reload over here. Whoops. All right, here we go. Wow. Now I have him in my web page as well. All right, so perhaps the other most compelling use of a web page is to have links to things, right? This isn't much of a destination right now. So let's go ahead and make this thing even more hideous and have a list of my favorite links. All right, so I'm going to go ahead down here, and I'm going to make another division just so things end up on their own line. But again, I'm paying little regard to aesthetics for now. Let's go ahead and say the following. I want a list. I want a bulleted list. So it turns out, per your little cheat sheet there, there's this thing called an unordered list. UL is its tag. I'm going to close it in advance just so I don't forget. And then you can have one or more list items, LI. In this list item, I'm going to say CNN is my favorite web page. And I'm going to put, say, the Crimson is my second one. All right, unfortunately, these aren't links yet, but let's see what the effect is. I'm going to reload. All right, and now way at the bottom there, I do in fact see it. And just so that we make this more clear, let's do style equals font size 24 point, just to make it more readable. All right, now it's even bigger. Now let's turn those into links. So the syntax for a link is to use the anchor tag, which is an A, href for hyperreference, equals http://cnn.com. Close tag. And now notice, keep track of the symmetry here. Now I'm going to put the name I want that link to appear as, close anchor. And Vim is making things a little ugly here, but all I've written is an open anchor tag followed by an href attribute. The name I want to give the link here, close it. I save it. I reload. I click cnn.com. And voila, my first web page. See you Wednesday.